Welcome to the last video of Chapter 3. This last video is going to be a continuation of linear programming. So in the first video, we graphed our constraints, we found what's called the feasible region, the shaded region, and then we used that region to find a maximum and minimum of a certain objective function. So then what I told you is in this video, we're going to be doing word problems. Similar to the word problem from a few videos ago where you had the test questions and you only had a certain amount of time and you could only answer a certain amount of questions. So what we're going to be looking at today is we're going to be looking at real life scenarios that have some type of constraint that are limiting us in some way. In the case of this first one, we're trying to make a profit, but we only have a certain amount of time with which we can work. And so we're going to try to figure out what combination should we make of our items to make the largest profit. We're going to have to define variables. We're going to have to write the objective function and write the constraints, and then again graph them and find a maximum or a minimum. So let's just jump right into question 1. Your factory makes fruit-filled breakfast bars and granola bars. For each case of breakfast bars, you make a $45 profit. For each case of granola bars, you make a $60 profit. To produce a case of breakfast bars, it takes 3 machine hours and 5 labor hours. To produce a case of granola bars, it takes 5 machine hours and 3 labor hours. The factory has a maximum of 150 machine hours available and a maximum of 122 labor hours available. How many cases of breakfast bars and granola bars should the factory produce to maximize the profit? Okay, there's a whole lot going on here. So, before we do anything, one thing I'm going to tell you is really important about these problems is the question that's being asked. So I would always, before you do anything, identify the question being asked, because that's going to help us in the whole problem. Okay, completing the table, we're going to skip for a minute. We're going to go right down to defining our variables. So here's what's going on. We work at this factory, we make breakfast bars and granola bars, we want to make a profit, but we have a certain number of hours. So we can't just make unlimited breakfast bars and granola bars, we have a certain number of hours that we can use. So we are trying to answer this question in blue. How many cases of breakfast bars and granola bars should the factory produce to maximize the profit? Now, as we talked about earlier in the chapter, when defining your variables, look at the question being asked. What are you looking for? We are looking for how many cases of breakfast bars and granola bars. So X, I'm going to say, is the number of cases of breakfast bars, and Y is the number of cases of granola bars. Again, number of cases. Don't just write granola and breakfast bars. Number of cases. So then we need to state our objective function. So we got to ask ourselves, what are we looking for? Like, what is our objective? What is our goal if we're the person who owns this factory? Well, our goal in this case is to make money, of course. We want to make the most amount of money. And we can see that in the question. We are trying to maximize our profit. So our objective function has to do with our profit. We're trying to make money. Now we see in the question, breakfast bars will make us $45. Granola bars will make us $60. So if I have X cases of breakfast bars, 45X then will be all the money I make off of those breakfast bars. 60Y will be all the money I make off of the granola bars. So this is my objective function. One thing to point out that I pointed out before, it's always an equal sign. So in the earlier video, objective function is always an equal sign. Okay, next thing that we're going to have to do is write a system of inequalities. In some questions, this is going to say the constraints. And again, this is just what's limiting us. So if we look in the problem at what's limiting us, we are told we have a maximum of 122 labor hours and 150 machine hours. That's what's limiting us. So we don't have an unlimited number of hours. So we're going to complete that table above and then use it to write our constraints. First line we see is machine hours. The maximum we have is 150. The maximum labor hours we have is 122. Now we need to look at how long the breakfast and granola bars take on each of these steps. So starting here, to produce a case of breakfast bars, it takes 3 machine hours and 5 labor hours. To produce a case of granola bars, it takes 5 machine hours and 3 labor hours. Now that is meant to help us write our constraints. So we are going to write a constraint or write an inequality for each item that's limiting us. So the first item that's limiting us is the machine hours. And then we have the labor hours. We only have a certain number of those, so we have to work within the hours we are given. For the machine hours, if I have X cases of granola bars, 3X then is all the hours spent on the breakfast bars. I then have 5Y, all the machine hours that are spent on granola bars. When I add those together, they have to be less than or equal to the 150 hours I have. Similarly, for those labor hours, it takes me 5 hours for every case of breakfast bars, and then 3 hours for every case of granola bars, and that's going to be less than or equal to 122. There's 2 other constraints you are always going to need. If we think about X being cases of breakfast bars and Y being cases of granola bars, they have to be positive. It doesn't make sense for X or Y to be negative. We can't have negative cases. So you're always going to have X is greater than or equal to 0 and Y is greater than or equal to 0. Every problem is going to have those 2. Every problem is going to be in context. And so we need to ensure that X and Y are positive. Okay, so those are our constraints. That's it for this page. You're going to need to remember these or carry these constraints over to the next page where we are going to graph them. Okay, so part D, graph the inequalities. Label your axes and vertices, regions of the feasible region. So we need to remember those inequalities we had. We had 3x plus 5y is less than or equal to 150. And then we had 5x plus 3y is less than or equal to 122. We had x is greater than or equal to 0 and y is greater than or equal to 0. Okay, so these are the ones that we are going to graph, similarly to how we graphed in the first video. There's a few more tricky steps though. So first we are told we need to label our axes. So the x-axis in this case is the number of cases of those breakfast bars. And again, that's just from part A of this problem, how I defined my variable. Y is the number of cases of granola bars, again from part A. So we're almost ready to graph. The 2 bottom inequalities, those are easy for us to graph, so we can graph those. You are going to need a straight edge, I forgot to remind you. So if you don't have a straight edge, make sure you go grab one. If I do that, y is greater than, x rather, is greater than or equal to. That's just this axis. Greater than or equal to 0, being this way. And then if I do the y greater than or equal to 0, it's just going to be the other axis. So really all those 2 inequalities are doing is telling us that we're working in the first quadrant. Trickier ones to graph are going to be these 2. Both of them are in standard form, so we're going to have to do an XY chart. You probably want a calculator, so again, go grab a calculator if you need to. This top one, if I put my 0 in for x, I get 5y equals 150. So my y is going to be 30. If I put a 0 in for y, I get 3x equals 150. So x equals 50. Now, we're not going to graph those yet. You should be able to tell looking at these intercepts that we're going to have to scale somehow. Our boxes aren't going to be able to go by 1. If they do, we won't be able to get up to 30 and 50. So we're going to find all the intercepts and then figure out how we want to graph. This next one, if I put a 0 in for x, I get 3y equals 122. So 122 divided by 3 gives me 40.6. And then if I take that 122 and I divide it by 5, I get 24.4. At this point, we're going to need to decide how we're going to scale here. So I will tell you that each direction has 20 boxes. Okay, so if we decide to look at our x first, how far we need to get on the x. We need our x to get to 24.4 and to 50. So if we count by 2s, that'll get us up to 40, not quite there. If we count by 3s on each box though, we'll get up to 60. So we're going to label that. We have 3 here, 6, 12, 18. So I'm going to label every other box just because I don't have a whole lot of room. 24, 30, 36, 42, 48, 54, and 60. Now on our y's, we need to get to 40.6 and 30. So again, if we count by 2s, we're only going to get up to 40. We need to get up to 40.6. So I would suggest counting by 3s again to get us up to 60. So again, we'll scale up. I'm going to do every other box just because I don't have a whole lot of room. Okay, I think we're ready to go now. I'm going to do those green ones first. So I have 0, 30, it's right here. And I have 50, 0, which is about here. Again, use a straight edge. If you don't use a straight edge, you're going to have a lot of problems. Don't forget we need to shade. So if we plug in 0, 0, we get 0 plus 0 is less than or equal to 150, which is true. Again, if you actually want to shade, you can. I do the arrows just so that I don't have too many shadings that overlap and confuse me. For the red one, I have 0 and then 40.6. So I have 36, here's 39, so 40.6 is right above that. 24.4 is about here. So I have 0 plus 0 is less than or equal to 122. So again, this way towards the origin. So our final overlap where all three, the blue, the red, and the green, overlap is right here. Okay, so we have 4 points on our feasible region. We have this point right here, this point, and that one. So the question asks us to label the vertices of the feasible region. So this one right here, the origin is 0, 0. The one at the top is 0, 30. The one at the bottom is 24.40. This one, I'm not sure. It doesn't fall on a nice, neat square, either because it's not supposed to, or because my lines aren't straight enough. So I gotta figure out how am I gonna determine what that point is. You can't just guess, I'm sorry to tell you. So let's think about earlier in the chapter. How did we figure out where two lines intersected? Well, we solved the system. Two options, we could solve graphically, or we could solve by substitution or elimination. Graphically, in this case, obviously didn't work. So I don't have a nice, neat point. So what I'm going to have to do is look at those two lines, so the red and the green one, figure out where they intersect. So I'm going to solve that system all the way over to the right. I have 3x plus 5y equals 150, and 5x plus 3y equals 122. So what I'm going to do, if I eliminate my x's, I can multiply the top equation by 5, multiply the bottom equation by negative 3, so then I'll have 15x and negative 15x. On the top, I get 15x plus 25y equals 750. The bottom, I get negative 15x minus 9y is equal to negative 366. When I add, those x's cancel, and I get 16y is equal to 384. Dividing 384 by 16, I get 24. Using my top equation then, I get 3x plus 5 times 24 is equal to 150. 5 times 24 is 120. So 150 subtract 120 is 30. 3x equals 30, which gives me x equals 10. So this point here is 10, 24. Again, you can't just guess. We need to actually solve the system so we know that that is definitively the correct point. Okay, we're almost done. Now down to part E, we need to use a table to find the maximum. So this is going to be the same way we did the table before. One side will be xy. The other side will be in terms of our objective function, which if you remember was 45x plus 60y. So we have our point 0, 0, 24.4, 0, 0, 30, and 10, 24. When I plug 0, 0 in, of course I just get 0. When I plug in that 24.4, I get 45 times 24.4. Now let's think logically about that though. X is the number of cases of breakfast bars. We can't have 24.4 of them. So because of that, we're really going to do 45 times 24, whole number of breakfast bar cases. And we get $1,080. 0.30, we're going to do 45 times 0 plus 60 times 30, which gives us 1,800. And then lastly, we're going to do 45 times 10 plus 60 times 24, which if you trust me, I will tell you that that's $1,890. Okay, remember, in this case, we're not finding a maximum and a minimum, just a maximum. We want to make the maximum amount of money, which we see is that amount of money at that point. So the last part in a problem like this is to answer the question using complete sentences. So you need to tell me what the maximum is and where it occurs in context. So I'm going to say, we should make 10 cases of breakfast bars. So that's that X. And 24 cases of granola bars. So that's the Y. For a maximum profit of $1,890. So again, where it happens and what the maximum is. Okay, so I know this problem is tricky, puts together everything from the chapter, but it's okay. When you guys come to class, we'll do an example together and we'll work through this. If you have any questions, please make sure you write them down. When you come to class, make sure you have a calculator and a straight edge, and make sure you're ready to go. If you have any questions, write them down or email me. Otherwise, I will see you when you come to class.